everyone. I'm so excited to see you all on this Saturday morning. And, you know, this is a heavy topic for Saturday morning, but it is so inspiring. And you're about to meet some true American heroes. And I'm so excited for you to learn about what they're doing. But first, I wanted to repeat some of the statistics that you all just saw in that video, because they are really staggering, and I think they bear repeating. There are more, by the way, I'm Katie Couric. Hi, sorry, I forgot that. There are more than 7,000 known rare diseases. 30% of children with a rare disease will not live to see their 5th birthday. 400 million people globally have a rare disease. 400 million people. 95% of rare diseases have no approved treatment or cure. So as I said, we're about to meet some heroic people who are on the front lines of the patient advocacy movement for diseases that many of you, honestly, I hadn't ever heard of. So I'm excited to be joined by Tania Simoncelli. She is the Vice President of Science in Society at CZI, the Chan Zuckerberg Initiative. Jennifer Canvasser, who founded the Necrotizing Enterocolitis NEC Society after losing her 11-month-old son, Micah, to the disease. Nasha is the co-founder of Citizen. That's a patient-directed healthcare platform for rare and complex diseases, a program she launched after her daughter Amara was diagnosed with FOXG1, and they were in the video that you all just watched. And finally, Dr. Monko Lek is a rare disease researcher who is also a rare disease patient. So there is enough brain power, excuse me, on this stage to save the world. And that's really what they're all doing. So let's just start by giving them all a round of applause. Tania, I'm going to begin with you. I know you've been at CZI for almost 7 years. So why don't you explain the impetus for launching this flagship project, Rare as One?
Sure. First of all, thank you so much, Katie, I just want to thank you on behalf of all of us, not just for hosting us here, but for just your extraordinary commitment to patient advocacy and just all of the advocacy that you've done over the years. It's just incredible for all of us to be here. So thank you.
Thank you.
So the impetus for Rare as One was really sort of twofold. I mean, first, it's just the extraordinary unmet need and the urgency in rare disease that you just re-articulated in talking through some of those kind of unbelievable statistics. I think people hear rare disease and they think, oh, well, those are really rare. That doesn't happen to me. But it turns out that on average, 1 in 10 Americans faces a rare disease at some point in their lifetime. It is not, collectively, rare diseases are not at all rare. They're quite common.
In fact, what is the threshold to be considered a rare disease? Because I was shocked by this as well, Tania.
So in the United States, we define a disease as rare if it affects fewer than 200,000 people. But what's important to understand is of these 7,000 plus rare diseases, many of these diseases are considered ultra rare or much more rare than that. So many of them affect more like 2,000 people around the world. It's also really confusing because we actually aren't very good at knowing how many people are impacted, because there's this extraordinary diagnostic odyssey in rare diseases where many patients remain undiagnosed for many years, don't know what they have. We're still discovering rare diseases every month. So this is an ongoing global health crisis that is actually getting bigger rather than smaller.
So talk a little bit about CZI and what you all are doing and how it started and why.
Sure. So we recognized there was this extraordinary unmet need that fewer than 5% of these diseases have any FDA-approved treatments. And the problem in rare is that the traditional academic research model is really failing these diseases. And what we observed was that more and more, really over, I'd say, the past 15 years, there's been this rise, this sort of proliferation of patient advocacy groups that are really going beyond what traditional patient advocacy groups have always done and do really well around disease awareness campaigns and generally raising money for their disease. And they're actually taking on these incredibly active roles in driving research forward. You heard David say in the video, I'm not going to wait for the academic research establishment to catch up to me, to my disease. I just need to go do this myself. And so how are they doing this? They're doing this by recognizing that the most important thing that they need to do is to build a really, really strong, research-ready patient community, patients who are willing to help move the goalpost, share their data, share their specimens. They're doing the work to build research assets, to attract researchers to the disease, to say, look, we can build a registry, we can build a biobank so it's easier for you to study the disease. They're de-risking their diseases, making it easier for them to study. And some of them are doing things like going back and getting a PhD themselves, like you saw Tracy in the video, and recognizing that they just really want to take on the role to drive this forward. So we set out to say, this is happening. Some of these groups were making unbelievable progress, completely changing the research landscape in their disease areas. And they were doing it on like really few resources, like scrambling together, doing bake sales and, GoFundMe campaigns and having a few individual donors come in and help them. But there were no major philanthropic organizations. And certainly the federal government was not directly funding patient communities. And so I set out to build a program that at its heart would really recognize that patient communities are absolutely central stakeholders in biomedical research, and that we would actually directly fund patient communities and really learn alongside these groups to figure out how do we optimize the power of patients to accelerate research and develop new treatments and cures in rare diseases. And that's what the Rare as One project is about.
And of course, a lot of these patient communities have a lot in common when all is said and done. And we'll talk about that in a moment. But first, I want to, Jennifer, talk to you about your son, Micah, who, as I mentioned, died of complications from necrotizing enterocolitis, or NEC, just before he turned 1, which is, I know, must have been an unbelievably heartbreaking journey for you, Jennifer. So tell us about NEC, because I don't know much about the disease and what treatments were available when he was diagnosed.
Yeah. So necrotizing enterocolitis, also known as NEC or NEC, is an intestinal disease that typically affects babies who are born either prematurely or with a medical condition. And it is very aggressive. So often when these babies are being diagnosed, they have become incredibly unstable. Often it's a medical emergency and they're rushed to surgery. And sometimes the babies don't even survive past a few hours or days. So it's very devastating. There is no way to prevent the disease and there is no cure for the disease. So you can imagine this is a really urgent issue that our families are facing. And so after Micah had passed away, I was learning how to function, live, breathe, eat, sleep without my son in my arms. And I looked around for a nonprofit that was working on necrotizing enterocolitis, and I was really shocked to find that no one in the world, there was not a nonprofit anywhere in the world that was bringing the community together to advance research, education, and advocacy. And there was no way that I could experience the pain of that void and not do anything about it. I knew that I had a little bit of resources and skills and background that I can help. And so that's why I founded the Next Society.
How many people are affected by this disease, and how hard was it, Jennifer, to actually contact all these people, because they must have been sort of far and wide? How did you kind of build that network? Because you have to first know people who are experiencing the same thing.
Yeah, absolutely. So NEC affects about approximately up to 10% of the babies that are in our NICUs. and about 50% of those babies will die from NEC. So it is really a devastating diagnosis. I would say that we've been able to connect with families through social media and virtually. Like, they find our website, and now we have created kind of a platform where families can find us, get resources and empowerment information so that they know they're not alone. They're not feeling isolated like I was when Micah was diagnosed and when he tragically passed away. So thankfully, we've been able to connect the leading clinicians and scientists and now family advocates and bring everyone together, and we are advancing the research in hopes that we have a world without this really devastating disease in our future.
We're talking about a lot of babies, Jennifer.
Absolutely.
Right? How do you have a number?
It's about 500 babies who die from NEC in the U.S. every year, and then thousands more are diagnosed and they survive, but they often suffer with lifelong complications. They have short gut syndrome, cognitive impairments, and so forth. So it's a very devastating diagnosis.
I know, Nasha, as I mentioned, your daughter, Amara, has a rare disease called FOXG1.
Yeah.
And it's a neurodevelopmental disorder caused by a mutation in the FOXG1 gene, which is critical for brain development. We saw Amara. Tell us about some of her first symptoms and how it's affected her development.
Yeah, so, Amara was delayed in the beginning, but our pediatrician just kept telling me that, hey, some kids develop later, don't worry about it. And then she started actually having seizures. And in many ways, the seizures really saved us because we were able to get a genetic diagnosis. We were able to get genetic testing where other families have to wait many years before a doctor will actually put that testing forward. So she started having seizures. She is very, very lucky in that she is mobile. When she was diagnosed, I remember the expert on FOXG1, this doctor, told me that she would never walk. She would never talk. She would have a lifetime of seizures. She'd probably be eating with a feeding tube. And this is true for the majority of our children. But at 2.5, Amara started walking. And that really took me back, that the leading expert had literally told me when she was diagnosed, which crushed me, that she would never walk, right? And so, but yeah, most of our kids are suffering. And it's also just the in and out of the emergency room and the hospitals and the impact on the entire family. Even Amara, one of us has to sleep with her every single night. My husband or I, she has tremors at night. We don't know why. She'll spend days that she's just crying or screaming. We have no idea why. We don't know how to fix it. So it's a very difficult condition.
Tell us about the foundation that you started, and it's pretty amazing what you've done, by the way.
Thank you. So the foundation, I did get together with other mothers and fathers, and it was, again, do we wait for research to come and help us, or do we help ourselves? And so we went ahead and we raised millions of dollars, and we built mouse models and cell lines. And we're really lucky in this time in science that we have genetic therapies, we have gene therapies. And many times, your doctor or researchers will just think you're stupid because you're a patient or a patient advocate or a parent. You don't have a medical degree, but actually a lot of this is learnable. And what we have is the lived experience and the desire to create this change just in a much more rapid rate than anyone who is just their career. And so we have developed a gene therapy. We did it completely on our own. We didn't have a single grant mechanism except for when Tania came in with CZI to help us. No federal grants, no state grants, nothing for patient groups. And in 7 years, we built a gene therapy. Even a pharma company would have probably take twice as long, if I'm honest. We did it on a shoestring budget, and now we're raising funds to get to a clinical trial.
And what's amazing is pharma started expressing interest and learning more about the disease because of your research.
Right. That's how it works, right? Once you get research out there, pharma's like, okay, it's de-risked, there's understanding, there's a patient community, it's organized. If I run a trial, you'll recruit for me. And this is the power of really patients coming together.
I know that Nasha, CZI is supporting something you're doing, as I mentioned. It's called Citizens. It's the foundation. Can you all hear me okay? Good. Okay. It's the foundation you co-founded in partnership with the FOXG1 Research Foundation. You're developing something called a digital natural history study using machine learning. Okay, that sounds a little like Latin to me. So help us out.
a lot
What
of
is
words.
that?
Yeah.
What is that? What is a digital natural history study?
Yeah, it's a lot of words. So actually, Citizen is a company, and the foundation, our FOXG1 Research Foundation, is really focused on finding a cure for FOXG1. But in that process, I realized that there's no way we could find a cure without understanding the patient's symptoms across our community, and it's impossible to actually figure that out in the current model where, you have academic centers set up across the world. Patients go in, tell people about their symptoms, that gets captured. That just doesn't work if it's a rare disease. Our patients are so few, they're spread out around the world. And so this is where I really felt, and my background is in tech, that why don't we just collect the medical records? And we can use machine learning and AI to extract information from those medical records, and you have human review, et cetera. And then we can compile kind of a database of just what symptoms our patients are having. It actually seems very obvious, and you would sort of think that this already exists. That, if you see a doctor with a symptom, they go into a database and they could see all the other patients with that same symptom, what they're going through, but it's not like that at all. You are basically, reliant on that doctor and that expertise. And so this is really a way to create this platform where we can follow the patient through their entire journey, get every information. Patients have access to their own data, which, by the way, I don't know if anyone's tried to collect their own medical records. It's very difficult. So we give access to patients. And then we can do a lot of stuff to actually push research forward.
So this is for patients with FOXG1?
It's actually
for all rare diseases?
It's all rare diseases. So, really I started the platform. It started in oncology, then we moved to neurology because of Amara and everything we were doing. And now we've opened up to cardiology and we're going to different diseases. But the idea is this really becomes a platform where any disease community can come. All their records can, be collated. It helps the patients, and then it drives research.
That's amazing. I know, Tania, and I'm sure we're going to be hearing a lot about AI during South by Southwest, but it does have the power to transform a lot of things, including rare diseases. But there are also some hurdles that you face in terms of accelerating this change. So can you talk about both sort of the challenges and the promise of AI? And Monkel, I promise I'm going to get to you, you brave man who's a part of this, the She collab, for crying out loud. Poor Monkel, he's like, hello, what about me? You're next. But before we do, Tania, can you talk about AI? Because, we're all afraid of it on some level. Is it going to take our jobs? How are we going to deal with it? But in medical research, it is an amazing tool. So can you just talk about that?
Yeah, so I think everyone in the rare disease community is recognizing that there could be some extraordinary applications of AI, large language models, machine learning to rare diseases that could really catapult this, research and the development of new treatments. But there is sort of a word of caution here, and the problem with this is that the biggest challenge in rare disease is that we haven't studied most of these diseases, that we don't have natural history studies for the vast majority of these diseases. We haven't characterized them. We haven't generated sufficient data that you need to power these AI models. Right? So right now, if we were to run large language models and try to make predictions about which diseases, which treatments might work for which diseases, existing treatments that we already have out there, or how you might point the way to developing new treatments or identifying new targets, those models are going to bias toward more common diseases where we have generated lots of data. Now, that's not to say that it's impossible. We have to sort of build this. It should really galvanize us to do even more now, to build and to do the research, to generate more data on rare diseases so that we can actually leverage the power of AI.
And so once you gathered the data to create these large language models, which I guess is just the foundation for AI, right? All the material that's been amassed, what kind of exciting developments might happen for people on this stage or people with rare diseases everywhere?
Yeah, so I think we're going to be able to start making predictions, understanding things like what happens, what triggers disease in the first place. That's really interesting. So why do healthy cell states start transforming into disease cells, disease cells? What happens in cancer? What happens in all the neurodevelopmental disorders? What happens when you have one mutation, one specific mutation along your FOXG1 gene versus a different mutation? And we can start actually making predictions about what you might expect to see, rather than having to wait to have all the data assembled or all the patients assembled. So that's really interesting. I think we might be able to start making predictions about potential therapies, about repurposed drugs, like opportunities for repurposing, by starting to really understand and pull data and make predictions on, diseases that may have common pathways and things like that. I think one of the near-term opportunities that I'm really excited about is really addressing the diagnostic odyssey that I referenced earlier. It's astounding to me that on average, it's still taking us 6 years for a rare disease patient to receive a diagnosis.
That's because doctors can't necessarily know about how many did I say?
More than 7,000.
Yeah, more than 7,000 diseases, right?
That's right. So you go to medical school for 4 years, there's no way you're going to learn about 10,000 diseases. And even if you're a specialist in a particular field, you're still not going to know about all the rare diseases. And the chances that you're going to come across more than, say, one patient with a really obscure rare disease in the course of your work as treating patients is really unlikely.
Yeah.
But this is where AI, large language models can really step in. You can actually start to amass not just the knowledge of that one expert, but the knowledge of all experts across like a long period of time.
Put symptoms in a database, right?
And then
have. Right.
That's right. And you could sort of run case reports of individuals that have undiagnosed diseases or where you don't know what's going on against these large databases that could actually start pulling out some of these terms and predicting, oh, this person may have this disease, and really ranking in priority. Now, these models aren't going to necessarily solve everything, but in conjunction with experts, working together with experts and ideally groups of experts from different disciplines, now you might actually be able to start to solve some of these undiagnosed cases.
I imagine some of these rare diseases have common characteristics, and
That's right.
They're looking, and they can look at them in different subsets. Monkel. You were diagnosed with something called limb-girdle muscular dystrophy, or LGMD. And similar to Nasha, you wanted to learn more about your disease. Tell us about your diagnosis, and what about your patient experience that drove you to become a certified expert?
Yeah, sure. So my journey is very similar to Nasha and her family, and that journey is very similar amongst all rare disease patients with trying to find out what is wrong. So as a young adult, I realized that I had muscle weakness and fatigue, and things that were very easy to do were now becoming very hard to do. So day-to-day things. So like everyone in this journey, I would go from doctor to doctor to seek answers, like what is wrong with me? And they'd go through a battery of tests. And first of all, I got a diagnosis, a clinical diagnosis. So it's a more high-level diagnosis that I had some rare form of muscle disease. But what I really wanted was a genetic diagnosis. So what was defective in me that was causing this disease? And that took over 10 years to actually receive. And this is where the disappointment started, or maybe a difference in expectations. So when I got the genetic diagnosis, I thought, well, this is the start of a journey of getting treatment, et cetera, et cetera. But then I realized that it wasn't that. And my neurologist said that you have this disease, a rare form of limb-girdle muscular dystrophy. It's caused by this gene. And there is no treatment out there, and the best you can do is look after yourself, drink a lot of water, and live a nice life. And that involved coming to see them.
Drink a lot of water.
Yeah, I know. It's kind of random.
I can think of something else I'd be drinking.
So, and with that, just come and see them once or twice a year, and they would jot down and pretty much tell me something that was obvious, that my muscles were getting weak. And for me, this was very disappointing to hear. And so one thing I haven't shared publicly a lot is that I'm kind of obsessed when things are broken. I need to know why it's broken and how to fix it. And in this case, my body was broken and I wanted to know how to fix it. So there were 3 areas that I really wanted to concentrate on, and it required me to become a certified expert. And the first was, why did it take so long to get a genetic diagnosis, and how can we accelerate that? Because as everyone has explained, it is such a long journey. And the second is, are there treatments out there? Because I wasn't going to accept that there were no treatments out there. And the third thing is, if there weren't, then how do we go about developing it?
You're doing research at Yale, and I'm curious how your experience as a patient and a researcher has driven you, and I'm sure your fellow scientists. And secondarily, Monkel, how being an Australian Asian man, we had originally said Asian, and Monkel was like, everyone's going to be so confused because my Australian accent. Yeah. But how your ethnicity has actually affected how you're approaching your research.
Yeah, that's a good question. So first of all, I'll break it down into the 2 parts.
Yeah,
For the first part, being a patient. So when I finished my PhD in Sydney, Australia, where I grew up, it took a few weeks later, I packed up everything, and my wife and I went to Boston. And what I wanted to work on was some of the cutting edge technologies that were available at both the Broad Institute and Massachusetts General Hospital, where I worked. And we did some amazing work there in trying to get to genetic diagnosis faster by building resources and tools to actually do that. But the patient in me was thinking, yes, we can get the genetic diagnosis faster, but am I just delivering bad news faster to patients, as I explained in the first response? Because that is not the end of the journey. That's the start of the next journey. And the reason why I wanted to start a research lab at Yale is I wanted to work on the other part of the patient journey, and that's understanding, why does this gene cause this particular disease, and how can we design genetic therapies to actually address that cause? So that's how it's changed my perspective in terms of that sense of urgency, and also that focus on the whole patient journey, and not to be detoured by curiosity. Sometimes it is a massive detour sometimes. And the second part, being Asian. So one thing you realize when you're in biomedical research is how biased it is. A lot of research participants are of European ancestry, and therefore a lot of our knowledge in biomedical research is based on European ancestry.
And mostly male European.
Yes. And this impacted me personally. Why it took so long to find a genetic diagnosis for me, and over 10 years, is when they first reported my rare form limb-girdle was rare. It was only rare in Europeans, but most people, because of the implicit bias, just concluded it was rare in general. And therefore, if you look at the gene, the mutation in my disease, you'll find that it's actually quite common in East Asians and South Asians, and I'm of Asian ancestry, and it would have rapidly reduced that journey, having that extra information on ancestry. And the way that's impacted my research is that it's motivated me to work on a project that's funded by CZI to work with a community-based organization called the Asian Health Coalition. And we're working on trying to educate the Asian American community on the importance of genetics plays in terms of muscle development, and its impact on aging, and also response to exercise, and also disease. And not just the education, but to build a collaborative network so that there are ways that they can donate their muscle tissues. It is a big ask due to the pain and discomfort, but they can donate it. And it's important because I think we're going through this genetic revolution in how we can use genetics to actually improve health outcomes, and that's in terms of disease susceptibility, disease progression, and also how to live a healthier and longer life. And I don't want my fellow Asian Americans or Asian Australians to actually miss out on this revolution. And so for it to have impact on the whole diversity of the US population that we have. And that's how it's sort of like
That's amazing.
impacted
It's
that.
so important. I want to clarify, did you get your PhD, Michael, after your diagnosis?
Yes.
And how old were you when you were diagnosed?
I was around 25 years old, so it's been a long journey.
You're not that old. But what were you going to do if you hadn't gotten a PhD in your particular area of expertise?
It's not very inspiring. My life would have been playing computer games every night, maybe streaming on Twitch, and this has dramatically changed what I wanted to do in life. I didn't have much ambition as a 20-year-old.
Well, thank you for getting a PhD and focusing on this, because so many people are going to benefit from your area of expertise now. I'm curious, for all of you, how has CZI and Rare as One propelled your work, and where would you be without it? And I'm not blowing smoke up Tania's ass, but I do think it's really important, because I think when you have these rare diseases, you feel like you're out there alone, and that nobody knows your experience. And even with cancer and my husband, I felt very alone, despite the fact that 1 in 2 men and 1 in 3 women will be diagnosed with cancer in their lifetimes. It's a very harrowing journey. So I'm curious if you could talk about the difference Rare as One has made in your work. And Jennifer, why don't you start?
So CZI has completely transformed what the Next Society is able to do. Before CZI came to support and help our organization, it was myself, someone who I had met who had lost her daughter, and my mom trying to do everything all at once. We had absolutely no infrastructure, no long-term funding, sustainability. There was nothing. And I will also say that I was not interested in doing the fundraising because I wanted to do the work to advance the research. I wanted to be at the table helping to propel the mission forward. And fundraising to me felt like it was sidetracking, and it was slowing me down from doing the work. And so CZI came, and the Rare as One network, and it has allowed us to have a professionalized staff now. We have actual employees who are paid, and infrastructure. We have long-term sustainability, and so we're actually have now the capacity to really see our vision through to a world without NEC. And so it's completely transformed what's possible for our babies and our families and our community.
Nasha, what about you?
Yeah, as I mentioned, there is nowhere to go and apply for a grant if you have a rare disease. And so when Tania started CZI, the entire rare community was like, finally, there's somewhere. And they're not small grants, right? They actually make a big difference. For me, I really wanted to make an impact around the digital natural history study. And I felt like that was important to all rare diseases. When I joined Citizen, the company was focused in breast cancer, which made a lot of sense. It's a big market. And they weren't really willing to take that risk to start a rare platform until I got CZI involved, and we got a grant, and we were able to use FOXG1 as the guinea pig. And I also brought in a couple other foundations, and we started that pilot project, and it was still a pilot project. Let's see what happens. And it was so successful, and we had so many patients join, and we had amazing research, and it drove actual pharma companies to start working on the diseases that it transformed the company. So none of that would have been possible, honestly, without the CZI grant.
And Michael, what about you? I mean, how has it sort of turbocharged your work?
Yeah, so it's allowed me to work with patient foundations, and a lot of these patient foundations fund a lot of my lab, and the way that it's accelerated the research is it's allowed us to do what we do best, and that's research. We're horrible fundraisers because we're not trained to be fundraisers. And the great thing about working with patient foundations that they're laser focused. They don't detour. They have only one plan, and then that's to advance their disease, knowledge in their disease, and also treatment. So one good example is we have a good fortune of working with a patient foundation called Cure Rare Disease, and they kind of summarize sort of like the mindset of patient foundations, where patients are now not satisfied to sit on the sideline anymore, and and watching someone else try and solve their problems. They want to drive the solution, the research, and not just fund the research, but also create the collaborative networks with academia, with industry, and also with regulatory, because it takes a village to actually develop these treatments. And so it's great to work with foundations that have that mindset, not just provide the funding, but also provide all the other resources that you need to get there.
The patient advocacy movement is just amazing. I mean, the fact that so many people are getting involved and not sitting on the sidelines and ushering in not only awareness, but obviously more scientific research. I mentioned early on that there are probably a lot of Venn diagrams, not only in the sort of the biological genesis of some of these diseases, but also the approach you're taking to do your work. So what have you all learned from each other and other rare disease? Because how many rare diseases do you fund, Tania?
So we funded a network of 50 organizations that are all, so Jen is part of that network, her organization, that are all working. These were fairly early stage organizations. Most of them had no paid staff, et cetera. And we're funding them and helping them to build their scientific and organizational capacity. So that's our Rare as One network.
Yeah.
But we're also funding additional groups like Nasha's project to sort of fund patient-partnered research projects, tool development in partnership with patient communities. The whole idea is patients should really be at the center of this and really helping to drive it. So all in all, we funded about, I would say, 85 patient organizations across the whole program, where 50 of them are within our Rare as One network, and then another 35 grants that have gone to, in part, to patient communities. So that's about the sum so far.
That's a sizable amount of cabbage, if you know what I'm saying.
We just closed our third round. The Rare as One network is actually a competitive grants program where patient communities apply to become part of the network. We just closed our third round, and we'll be funding, I hope, up to another 30 groups to join the network. So we'll soon have over 100 groups that we funded.
That's an amazing commitment. Is it tacky for me to ask how much money you've spent on this?
So we've spent almost just over $95 million to date.
That's amazing. That's amazing.
And, yeah.
I got diverted on the money stuff, but tell me what you all have learned from each other quickly.
So I would say being part of the Rare as One network has allowed us to figure out together how to build our infrastructure and our capacity. It's not so sexy, but it's really fundamental to being able to exist long term and not burn out and continue to serve our community and advance the research. And then we've also built and modeled like our research roundtables off of each other. It's a closed space where researchers and family advocates can come together in a safe space to advance the research. So really fundamental learning.
Yeah. What about you, Nasha? What have you learned from these other groups?
You know, first of all, the groups, there's just a lot of support. I don't know what I would do without my other patient leader, advocates that are in the same boat as me doing the same stuff. I've learned a lot from groups that are further along that have actually found cures for their diseases, how they've managed to do that, how they've managed to raise the funds, how they've, worked with different scientists and researchers, the mistakes they've made. That has been just, I don't know what I would do without other people that have gone through this that I've been able to learn from to figure out how do we do it. And even now, what we've done in 7 years, looking back, I feel we could have done it in 4. And so now we're trying to help other groups not make the mistakes that we made. And so that's the idea.
And Michael, I know there are a whole panoply of neurodegenerative diseases. Last year I was here interviewing Brian Wallach and his wife, Sandra Abrevea, and Brian has ALS, and they've done extraordinary work. But oftentimes when you have these patient advocacy groups, they're sort of siloed. They're kind of competitive, honestly. I know that from my colon cancer advocacy work. And it's really hard to pool your brain power and even resources and efforts. So tell me what you've learned from other groups and how you're breaking down some of those walls.
Well, Well, first of all, what I learned from other groups is what a bunch of amazing people they are. When I went to the first Rare as One conference, I'm used to scientists sprinting to the lunch line to get to the lunch food. And these people are so amazing, these grantees. They were fighting over who got to help me sort out my lunch. And that's what a bunch of amazing people the grantees are. And in terms of breaking down the silos, it's probably trying to find common themes. As an advisor, coming to these meetings, common themes, common challenges as they have touched upon, and then making sure everyone knows that we all have the same end goal. And so talking about different ways we can data share. And another thing that I think breaks down walls a lot is funding the next generation of scientists because they're not so set in their ways. And it's funding the new generation because the scientists that made the discovery of the disease, they're normally in the retirement years. And just to remind people that we should be funding the next generation of scientists. Sorry, I have to say that as a scientist, a younger scientist.
That's
to
smart.
put in the plug for the
Makes
next
total
generation of
sense.
scientists.
It makes total sense.
And it creates greater engagement. And the next generation of scientists grew up in the information age, so they know the value of information sharing.
And Tania, what have you learned from this work? I mean, I do these panels and I'm blown away by all of you last year, this year, everyone who is a part of this community. Mm-hmm. It's so inspiring to me. So tell me about your experiences working with people like this on a daily basis.
Yeah, I mean, this has been a privilege of my lifetime. I mean, I actually came into the rare disease space after working for 25 years in science policy. I had worked across the gamut with advocates from all different sectors and areas, environmental activists and advocates and social justice folks and criminal justice reform people. And I love people who work in advocacy. But there's something really special about these advocates. And I think part of it has to do with the fact that nobody chooses to be a rare disease advocate. This is something that happens to them or to their loved one. And those who decide that they're not going to take that answer that you just heard, they were all told there's nothing you can do, go home and love your person or live your life or drink lots of water.
Or max out your credit card and that's
play lots of video games.
Yeah.
Right. And those who say, no way, like I am going to dedicate whatever time I've got or whatever energy I have, and I'm going to figure out how to solve this disease. Those are really special people.
And I was particularly moved by, I think it was Martha, who said in the video, it may not be for Cal, but we are going to help propel scientific breakthroughs for other people. And that is such a selfless act, I think.
That's right.
To be able to say, it may not help me, but it's going to help somebody else.
Yeah.
Is there anything in closing, because we're almost out of time, that this room and all their friends and networks can do to help either with what you're doing, raise awareness so they can pay it forward as a result of your work? What would you tell everyone here, Tania?
Well, I think the last thing I've learned is that, there's that line in the film where Tracy says, my money's on the patients. And, we built a program 5 years ago that was sort of a pilot program. Rare as One project started out as like, well, we're going to pilot this and see what happens, where we made a bet on patients. And I would say that bet is paying off in spades. Like we are seeing extraordinary results. In our Rare as One network, for example, 50 groups working for 4 years. These groups have actually engaged more than 6,000 researchers and clinicians from around the world in their networks. They've launched more than 200 research projects. We've got 17 clinical trials. None of that, there is no way, none of that would have happened without the tenacity of these patient leaders. So my message would be, we're doing this work We know that this works. This is a different model for research. It's patient-driven research. And my message would be like, we need more people to understand the value and the contributions of these communities. We need more funders in this space. CC High, we cannot do this on our own. And we are really looking for others to partner with, other stakeholders. And to the extent that all of you can raise awareness about this extraordinary work that these folks are doing and how important it is to really center patients in our healthcare system. And that includes in our biomedical research system. And that we need more folks understanding the value and contributions of these communities if we're going to do this incredible work of curing and managing and preventing these really, really challenging diseases.
And there's a place to go if anyone, has someone in their family or their friend group that has experienced something like this, that this place exists. Jennifer, what would you say?
I would say rare. A disease does not feel rare when it happens to you. I definitely never thought that my son was going to die from a rare disease. And so I would say there was no one who is more compelled to do this work than we are. We are relentless, and we will not stop until we have cured or prevented the disease that we're working on.
Yeah, I would second that. And to Tania's point, unfortunately, it all comes down to accessing funds. And right now, funders tend to give money to large academic medical centers, both federally, state level, and even large donors. And I would say we do need a different funding model. We need to start funding patient entrepreneurs who are actually proving that they're driving cures, not just research papers. We don't care about research papers. We care about actual medicine going into a human body and creating change. And that's what we need, is we need an entire movement and awareness around that.
Michael?
I totally agree with Nasha, being a researcher. I just want to add to that. Yes, I totally agree. Mainly being a patient, it brings meaning to, we've cured the mouse many times. We cured that same mouse many times. It's about time we start translating it. But what I would like the audience to take from this, from my point of view, is do advocate to local senators and government, mainly that, I go to a lot of charity events, and sometimes I think I watch mums, dads, families, friends sell cupcakes, do fun runs, and it's not sustainable, and we need help. And I think the biggest help would be from government.
And individuals, though, because you can't necessarily count on the government, right? Even with cancer, only 1 out of 10 promising research proposals gets funded by the NCI. So I think you have to figure out other methods as well. So I want to make sure I leave people, if they want to learn more, where do they go?
rareis1.org.
rareis1.org. And I, for one, am going to post that beautiful film that was so moving on my social media channels. And if anybody else wants to do that, can they do that as well? And do you have a petition or anything on your website? Because that would be a good idea too, don't you think?
Not yet, but that's a great idea,
yeah.
Katie.
Just throwing it out there. Anyway, we're exactly on time. I can't believe it. I always go over. Just ask my colleagues at the Today Show. So thank you all. Tania, Jennifer, Nasha, Michael, thank you for all you're doing, and thank you for being a part of this today.